tangent line. And we have two delimit definitions, one that looks like this. Right, you seen that one? And I think we did an assignment in which you had to identify F and identify A, correct? And now what we're doing is we're finding slopes without doing limits, correct? Like the power rule is wonderful. Okay? So you're gonna see there are questions on both assignments that are like this. The other one that is this one, correct? Okay. Again, they give you slopes of a tangent line. In other words, they're equal to this. The derivative of the function with a plugged into it, correct? Everybody with me on that? The derivative of the function with a plugged into it, correct? So remember, I gave you a number of assignments. You had to identify F, and you had to identify A, and that was it, right? I mean, it was like, okay, why are we even doing this? Well, now this is why you're doing this, okay? So if I look at this problem right here, is this 2.5? Nope, this is 2.6. I want this problem right here.
Is it 18?
Number 20 and number 21. Okay, it's under the test prep. And the reason I mention this is because when you guys get your results July 5th, I think that's when it is, I get the results the same day. And about 3 weeks later, I get my grade, which says, hey, this is what they did really well, this is what they did not do really well. What they didn't do really well is your fault, fix it. They don't say that, but that's what I think, okay? And this was one of the ones right here. So if you look at this one, I'm going to ask you this question. Do you know what F is?
I believe F is x cubed.
It is x cubed. Great.
And since x is approaching e, we just place the x with the e.
Okay, so what's A?
A is e.
A is E. Would everybody agree? Okay? Well, you don't want to do any algebra here, because you know it's equal to the derivative of F with A plugged into it. That's what it is. This tells you the slope of the tangent line at the value x equals A, correct? Are we okay on that? Well, do you know the derivative of this? You should be saying, Mr. Kruger, on the quiz, give us 20 problems just like this, because I know how to figure out the derivative of x cubed now, right? Grace, do you? Could you tell me what it is?
3x squared.
It's 3x squared. So now we just have to, our answer is going to be, we're going to plug E into here. Remember, E is a number, correct? And so that's going to be 3e squared. Boom! You're done with this problem. Is that making sense? Okay. Now this is the other form I showed you, correct? Do you know what F is? Yeah.
Square root of x.
The square root of x. Perfect. Do you know what A is? Remember, this will be the square root of A, correct?
25.
25. Notice that says A plus H. Oops, turning you too much. A plus H, 25 plus H. Where did the 5 come from? The square root of 25 is 5, isn't it? Everybody okay on that? So now, this is the same as x to the 1/2 power. So what's the derivative of that? I know Grace knows. Ella, do you know?
1/2 x to the negative 1/2.
Perfect. Would everybody agree?
Mm-hmm.
Okay, now, you gotta remember, this is the same as this. And you'll see me write this many times. Anytime you have a fraction, you're gonna have a radical. That's what this little funky thing is. It's a radical. This one happens to be the square root, which is x to the 1/2 power. Remember, if you get like a -4, a -3, or a -2, those are not square roots or cube roots or any of those.
Those are fractions.
Okay? This is a fraction, so that's where that's going to be. So now I'm going to put in 1/2 times the square root of 25, because that's what A is. So it goes from a very hard, scary looking problem to something you should know. Okay, does anybody know what the square root of 25 is? 5, right? So the answer to this has got to be what? 1/10. Everybody okay with that? All right. Then we have another one that's up on the window, and this is the definition of a derivative. Remember, the derivative is the expression that gives us the slope of the tangent lines at any x value on the curve, correct? It's a general expression. It will be in terms of x. And it looks like the limit as h goes to 0 of f of x plus h minus f of x over h, correct? That is this definition. So it's a general derivative. It'll be in terms of x. But if I knew an x value, I could plug it in and know the slope of the tangent line. Everybody with me on that when I explain it that way? So let's look at this problem, number 26. It's not written very well. This right here, there's a minus sign right here. It's hard to see. But this portion right here is f of x. So f of x is 3x squared, right? It's minus f of, pardon?
What is f of x?
Right here, this 3x squared. In other words, this first part right here is f of x plus h and minus f of x. So this 3x squared, so what you have here, it's hard to see, you have 3 parentheses x plus h squared plus 2 over x plus h minus 3x squared minus 2 over x. Well, what I have to do is factor out that minus, and it's going to be 3x squared plus 2 over x. You see how these two parts match up? Follow that? You got, so they're a little tricky, Jonah. They distributed the minus sign, right? So I had to factor out the minus sign. So f is equal to 3x squared plus 2 over x. I know that Ella and Grace know how to take the derivative. Ariana, do you know how to take the derivative of this? Ooh, you're giving me the evil eye. I love that. My oldest son is 36 years old. I've gotten the evil eye since, for 33 years. You want me to give you a hint? Okay.
It's 6x.
You're right so far. You don't have to be perfect. Just learned about this yesterday. I'll rewrite this.
Oh, is it -2?
Oh yeah, it is a -2 over what? Not the square root. Remember, this is x to the negative, this is 2x to the -1, so you're gonna get a -2, and then you're gonna subtract 1, and that'll be a -2, correct? So it's just gonna be over x squared. X to the -2 is equal to 1 over x squared. And so you take a look, once you know that, you can see it is C. Okay, is that helpful?
So these questions just asking us to find its derivative.
Exactly.
Cool.
That's exactly what they do. But it doesn't look like that.
It doesn't tell me to find it specifically.
No, but you have to identify that it's one of those three forms and said, oh, all they're asking me to do is find the derivative of the function, and either put a number in it or just leave it in its general form. But it doesn't look like that. Where they're saying, hey, do these people know the definition of a derivative? That's the way they check you. That's why they're there. And the reason I'm bringing this in, on Friday, I threw a couple of these questions in. Why? Because I did a poopy job explaining it last year. I gotta do better. Is that kind of making sense to everybody? Okay? All right. I have some notes I'm gonna give you. I wanted to make sure I talked. Did anybody have any other questions about either, any problems?
Okay, this one, because I couldn't figure out how to find the answer to calculator number 19, so.
Which one?
2.5. I took the look at your answer sheet and I was wondering, how did you get that? It took me about like 20 minutes to find it.
It says, when do the two functions have parallel tangent lines? So you have to take the derivative of both of them, right? Because those give you the slopes of the tangent lines.
Mm-hmm.
Okay, so since Ella did this one for us already, I'm just gonna write this. You should be okay that that's this.
Yep.
And you should be okay that that's this.
Yep.
Okay? And these give you all the tangent lines on G. These give you the slopes of all the tangent lines on F. I want to know when they're equal, so I'm going to make these two expressions equal. Okay? So I'm going to have 1 over 2 square root of x is equal to 3x squared. Would you agree with that?
Yep, I did get this problem done, but it just confused me a while.
Okay, so then you were able to solve it after this?
Yeah,
Okay.
but I
Would
want, because for a while I kept I got like to the negative stuff to like the -4th.
Oh, okay.
Like, so I want to see how you did it.
How I would do it? Now you want me to keep going?
Yeah.
Okay. So I would. Do you see where I get 1/6? I divided both sides by 3, or multiplied by a third.
What I did, I just multiplied both sides by 2 root x, then divided by 3x squared. Or did I do that? I forgot now. I know that was one of my things I did in one of my
I
attempts.
would have this. Do you see where I get that?
Let me take a look.
I multiply both sides. What I did is I divided this by 3, or multiplied by a third, I guess. And I multiplied by a third here, and that's where I got 1/6. And then I multiplied by the square root of x, but I wrote it in exponential form.
Okay, I'll give you my homework later so you can take a look at this problem.
But you know what? I'll step back. I'll do it this way.
I see how you did it.
Okay, are you okay yet?
Yeah.
Okay. So then I said this is 1/6, and I know this is the same as, I would add those exponents, so it gives me 2.5, right? So that's to the 5/2, right?
Mm-hmm.
Now, if I raise this to the 2/5, I would raise this to the 2/5. Would you agree? Now, why did I choose the 2/5? Because when I raise to a power, I multiply the exponents, and 5/2 and 2/5 are reciprocals, and when I multiply them, I get 1, or x to the first power. Is that making sense?
I think so.
Which is same as x. Now I go to my calculator and figure out what 1/6 to the 2/5 power is. I have to use the machine. And it says use a calculator. Thank you, God. Okay. And so that would be my x value where I have the same parallel lines.
I'm just gonna give you my homework here so you can see what I did.
Okay, yeah.
Because I did some weird stuff. I got a 136 at times.
I don't know what. I'm gonna get back to you,
Okay?
and then I'll look at it later.
Okay. Because this problem was really interesting.
Anybody else have any questions? Are we okay with this algebra?
Yep.
Yeah, all right. Okay. All right. Now, you can, if you want to write this down, you don't have to write this down. What is important, and I'm going to come back to you when I give you the notes, I think it's important that I never liked it ever as a math student. I had to know where everything came from. I didn't like it all of a sudden when, okay, here's the rule, just memorize the rule. Okay, now it's another thing to memorize. Okay, and so I'm going to, we're going to go through and do a bunch of different things, and we're going to figure out some derivatives. But I'm going to show you where 2 of these came from, okay? And so last year you learned trig, correct?
Mm-hmm.
Okay, and you learned something called trig identities, correct?
Yes,
And I
believe-
think you had to prove trig identities, am I right? And it was like, you guys didn't like it, be my guess? I always thought they were kind of fun, but
Well, the
you know.
trig identities were a lot easy. Like proofs I hate were the geometry.
Okay.
Like the ones
Well,
doing
okay,
8th grade.
in this class, you gotta know this trig identity.
Equals 1.
You gotta know that one, okay? That's my favorite one.
Yeah.
And then if I divide everything by cosine squared, you should know that one. And if I divide everything by sine squared, you should know that one, okay? And all I did is, I really know that one, and then I just divide by cosine squared, and then I just divide by sine squared, and I come up with the other 2.
I still have
Okay.
a trig identity sheet in my backpack.
Okay,
so
great.
will I ever need to write this down? If I already have the identities in my backpack?
No, no, you don't have to write any of this
Because I'm
down.
gonna work on this.
But I'm gonna show you something you need to know though.
Okay.
Okay. So, one identity you were told is this one. And you were told that this is equal to the sine of A times the cosine of B plus the sine of B times the cosine of A. Okay? You were told that. The other one you were told was this one. That this one was the cosine of A times the cosine of B minus the sine of A times the sine of B. Now, I don't have those memorized. I looked them up. Okay? I'm gonna use them in this in a second, all right? So what I'm gonna do is I'm gonna find the derivative of sine. And this is just some notation, so y equals sine of x. And I get rid of the y and say, hey, find the derivative of the sine of x. Well, I have no idea, except I know this rule, that this is the definition of how to figure out the derivative. I just talked about a sec ago. And you can't do this algebraically. It's impossible. But what I can do is use this rule right here. So I'm going to write this as the sine of x times the cosine of h plus the sine of h times the cosine of x. And then so I took this and I wrote expanded like that. I took this part, expanded.
So we basically just did sine of AB and replaced the A and the B with X and H?
Correct.
So it's the
And
same
then
formula.
I have that.
Same formula, different variables.
Yep, exactly. Okay? And then what I'm going to do is I'm going to take this and move it here, and I'm going to take this and move it here. So I'm going to have the sine of x times the cosine of h minus the sine of x plus the sine of h over the cosine of x all over h. So I just switched this one to here and this one to that. Everybody have that? Now, I'm going to take this and I'm going to factor out an x and I'm going to go get the cosine of h minus 1 over h plus, and I'm going to come up with two fractions. So they have a common denominator called h. I put these two together over here and I factor out a sign, and I took this one and put it over h. Everybody got that?
Mm-hmm.
Okay. And I'm going to take the limit now as h goes to 0. Now, the only thing that's going to 0 is h. So this cosine of x is going to be unaffected because x is not doing anything, only h is doing something. So my question is, does anybody have any idea what that limit is? You learned it a while back. It's 1, exactly. Okay? Plus. Now again, the limit h is changing, so it doesn't affect sine. It only affects this. Does anybody know what that limit is?
The one in the square, that would be a 0?
That's a 0. So what is sine times 0?
0.
So you're left with cosine of x. So if f of x equals the sine of x, its derivative is the cosine of x.
I'm just gonna write that part, the final bit down there, because that'll probably be a good thing to remember.
I'm going to give you a sheet, and it's going to be on there.
Oh, that? Nice.
I'm going to give you some notes, and it's going to be on there. But I want to show you where it came from. Okay?
Yes.
So you can just watch some of your writing down. The rest of you can just watch, and now I'm going to do the other one. Okay?
We're not gonna use the part, like, we're not gonna use the upper part of that though, right?
This here.
No, the middle bit, like that.
We're going to use this one now.
Yeah, but not like the middle bit, like.
All you need to know is this.
Oh, that's the only part that's actually worthwhile remembering.
Exactly. But I'm just showing you where it came from.
Yeah, so you're basically
Okay.
giving us backstory that's not needed.
Yep.
Okay, just wanna
Okay.
clarify.
Okay. So now I'm gonna take the limit as h goes to 0.
Should I
And it's
write
gonna
this down?
be, no, I'm gonna show you what the derivative of cosine of x is.
Is it a sine of x?
So it's gonna be the cosine of x plus h minus the cosine of x over h. So I'm gonna expand that. So I got the cosine of x times the cosine of h minus the sine of x, the sine of h minus the cosine of x over h. And I'm gonna flip these two around again. So I'm gonna have the cosine of x, cosine of h, minus the cosine of x, minus the sine of x, sine of h, over h. So I'm gonna write this, I'm gonna write the limit, as h goes to 0. I'm gonna factor out the cosine of x. In here, I'm gonna have the cosine of h minus 1 over h minus the sine of x, sine of h over h. Well, only h is changing, so it doesn't affect sine of x. But what's this? Limit 1. Doesn't affect the cosine of x, only affects this. What's that? 0. So what is cosine of x times 0? 0. Minus the sine of x. What is that?
Negative sine of x?
Negative sine of x.
I was off by 2 sine of x.
Okay. So if f of x equals the cosine of x, its derivative is the negative sine of x. I wish it was the positive, but it's not. So let me get you some notes. So, first part of the notes. Derivative of cosine, negative sine. Derivative of sine, cosine of x. Bingo, that's it. So if I give you this on the quiz, you're done. That's your work. So now let's take a look at this. Find the derivative if f of x equals 2 sine of x. So the derivative. It's going to be 2 times the derivative of the sine of x. What's the derivative of the sine of x? I come up here and look and see it's the what? Cosine of x. Bingo. Minus 5 times. It says what's the derivative of the cosine of x? It's the negative sine of x. So my final answer is 2 cosine x plus, because I'm subtracting a negative, so it's plus 5 sine of x. Boom, I'm done. That's my work. What do you gotta know? That the derivative of sine is cosine, derivative of cosine is a negative sine. That's the glitchy part. Everybody okay on that? All right. Now, we'll switch gears again. So you're gonna need your calculator. And I will do the first one, okay? So it says my function here is f of x equals 2 to the x power. So if x is 1, it'll be 2 to the first power. That's 2. 2 to the second power. 4. 2 to the third power, that's 8. 2 to the fourth power, that's 16. How did I get those? I just multiply by 2. Then I'm going to go to my machine. And we should be at a point we're okay with this now. And ooh, look at this. I still got my derivative up here. So I'm going to come up here, and I'm going to put 1 in there. And I'm going to write down 1.386, I'll put 3 in. Now, it says take that derivative, which is right here, which is my answer. So I'm going to go shift answer and divide it by f of x, which was 2. So I'm going to divide it by 2. And I get 0.693. Okay?
Okay, so then I divide it by 2.
Yep. So now I'm going to come back to my calculator. This time I'm going to do it to 2. And it gave me this number. But I don't want to divide it by 2, I want to divide it by 2 to the second. So I'm going to come up here and divide this by 4. Oh, I got 0.693. That's kind of cool. So I got 0.693 here, and I got 2.7726. All right. So now I'm going to come up here and do 3. And I get 5.545. I'll just write that. And then I want to divide it by 8 this time. Ooh, I get 0.693. Now I'm going to do it to the 4th. And I'm going to get 11.090, but I got to divide it by 16.
0.693.
Oh, you think it's the same thing?
Yep.
0.693. Now, you guys know what 0.693 is? I'm gonna go to the natural log, and I'm gonna type 2 in there. And I get the same number. So this is the natural log of 2, all those. So now I know that the derivative of x over 2 of the x, because that's my function, is equal to the natural log of 2. Again, this was f prime of x. I don't know what it is, I just know some numbers. I know what f of x is, it's 2 to the x, so I put 2 to the x there, and I get the natural log of 2. So that derivative must be the natural log of 2 times 2 to the x. Okay. So, in this row, you 3 are going to do that one.
Me?
Okay? Matthew, Ben, and Owen. You're just going to complete this.
That one column or the entire table?
The entire table with conclusion. Okay? On the back side, Austin, Grace, and Colin are going to do this one. Ella and Callan are going to do this one. And you two get to do this one. The only thing you don't know what f is, you don't know what the derivative is,